Hello students, welcome to this lecture number 6 on Ionic Equilibrium. In this lecture we are going to discuss very important thing in your Ionic Equilibrium chapter, that is the dissociation constant of weak acid and weak bases, and also we will discuss the pH and some numericals we will discuss. So let us take a instance of a weak acid HA. So weak acid we are taking, that is HA, and its dissociation equation will be like this. As it is a weak acid, you can easily understand that it will not be dissociated totally. Partly it will be dissociated, and there will be the equilibrium has been achieved between the unionized molecules and the ions, and this equilibrium we will reach, and we will able to establish a equilibrium constant, that is a dissociation constant of ionization constant. So let us, we have taken the initial concentration of this HA acid, weak acid, initial concentration, that is mole per liter, that is we have taken C, and initially there is no ions, and after the dissociation and when it attained the equilibrium point, and we have let us we have taken, that is the Ka, the dissociation constant of weak acid, dissociation constant, and the alpha is degree of dissociation. Degree of dissociation, very important factor, degree of dissociation. Okay, so alpha is degree of dissociation and K is the dissociation constant. And at the equilibrium, we can say that concentration of this unionized HA is C minus C alpha, and C alpha concentration and C alpha molar concentration has been in the ion. This amount of the HA has been dissociated. So we can get the Ka is C alpha into C alpha, and that is given by this, and we will take this C alpha square, and C is 1 minus alpha. So ultimately we will get a relationship, that is C alpha square and C minus 1 minus alpha. As alpha is much less than 1, so we can see 1 minus alpha is 1, so we can, the dissociation constant can be expressed in terms of its molar concentration, initial molar concentration, and its degree of dissociation is alpha square. Okay, so this is how we can understand, we can see the dissociation constant in terms of its molar concentration and degree of dissociation. What is dissociation constant? K, let us understand. K is basically a constant at a given temperature. We can write it is a constant at a given temperature. It is a constant at a given temperature, right? And at that temperature, the unit of this K, it is dimensionless. It is dimensionless in the sense that everything has been kept under a standard state of condition, that is a 1 mole. And what is K? What it interprets about the dissociation of the acid? It tells about this fact how strong the acid is. Means if the K is higher, means the acid is having the higher strength. K is higher means acid is higher strength. Means acid is higher strength. So you can write this. Higher strength. Acid have the higher strength. And K is lower means that is acid is the lower strength. And K is lower means acid having the lower strength. So the value of the K is very, very important. As for example, that is HF acid, hydrofluoric acid. Its K value you can see that is coming around 4 into 10 to the power minus 4, whereas the HCN, hydrocyanic acid, its K is 4.9 into 10 to the power minus 10. So you can see the dissociation constant of HCN is much less than the HF. So it is to be weaker than this HF, and practically it has been observed the HCN is the most weakest acid so far available today. So dissociation, from this dissociation constant we can able to predict about the strength of the acid. And another terminology, that is pKa. pKa basically minus log of Ka. This also gives the indication of the strength of the acid, but in that different, in the opposite way. How? Now if the pK value is higher, then the strength of the acid is lower. If the pK value is lower, then strength of the acid is higher. So here it is totally opposite thing. So don't confuse with the pK and Ka. That is notation, its meaning is totally different. When pK is higher means it is a weak acid. When pK is lower means this is the stronger acid. That is different for the K. K is higher means it is stronger acid. K is lower means it is weaker acid. So you understand this. And this can also, this also applicable, this formula also applicable for the base also. Base is MOH, this is the base, and the base has been dissociated and it will giving this ions, and it is also weak base. And for this base, the dissociation constant for the base is written as Kb, and it also be. So now we are discussing the dissociation constant, that is the Kb. Kb is given by C alpha square. So accordingly we now understand the dissociation constant for weak acid and dissociation constant for weak base. Weak acid is given by this Ka, and this formula is, you can see, that is Ka is equal to C alpha square, and for this weak base, that is Kb is equal to C alpha square. And how this value is going to interpret, what is the significance of the K, that we understand. Higher the K means higher the strength, lower the K means lower the strength. In case of pK value or pKb value, this will have the different notations, opposite notations. Higher the pKb means lower strength, lesser the pK means the higher strength. So now we are going to discuss the pH of the weak acid and weak base. Now we will discuss the pH of the weak acid. Already we came to the point where we have deduced that relationship between the Ka, dissociation constant of weak acid, that is C alpha square, and from this we can able to calculate the C is given by, so we can get C, that is Ka by alpha square. Now we know the pH is nothing but, what is pH? pH is nothing but minus log of hydrogen ion, molar concentration of hydrogen ion. So we can just put, we already understood from this equation that was made, that is C into alpha, that is the that we are taken not directly to the pH. We are going first, let us see the H plus ion concentration, that is C into alpha. Then we have put this value of the C So it should be coming on Ka by alpha square into alpha, and this is giving this, and this is Ka by alpha. And this pH value that we will get, pH equal to minus log of H plus ion concentration. So already understand what is that? This is minus log of Ka by alpha square by alpha, and this is the one relationship that we get, the very important relationship, that the pH of the weak acid that is given by this dissociation constant and its degree of dissociation. So degree of dissociation is you are seeing that is alpha, and it is K, and there is a minus log of Ka by alpha. Now this, the pH value can be have in other term, that is H into C alpha. Here we will put the value of alpha. By taking from here, that is, you can see that C into alpha. If we put from this equation, that we will get the alpha is equal to Ka by C. Okay, and this will be coming around the Ka into Ka, that is dissociation constant of the weak, Ka into C. Okay, now this pH is coming around, that is, we know minus log of H plus ion concentration, and we will get, we just put this value, so we will get the log of K into C, and we deduce it, we will found that it will be coming on a half log minus half log and minus half log C, and this will be coming around half of pK value minus log C. That is again a very important relationship between the pH and the pK value and log C. And here we get the, with the log K by alpha with this value. So there is a two relationship that we get. The pH you can calculate if we know the dissociation constant and its alpha, and if we know this pK value and its molar concentration, we can also put this value. In a similar fashion, for the base also we can have this relationship, that is what we get, right? But here we will get the POH, that is half of pKb minus log C, and after that we have to go by this formula, pH is equal to 40 minus POH. So we will put this value and we will get the pH of the base also. So you understood how we can able to calculate the pH and dissociation constant of the weak acid and the weak bases. You have to calculate the pK of, you have to calculate the pH. The pK of the acetic acid is given, the concentration of the acetic acid is given, the pH, the option has been given, then you have to calculate the pH. So for this pH, you will have this relation, that's a half into pK minus log C. So here half, pK value is given 4.74 minus log C, that is given log of So half minus 0.01 this, and it will give you log of this is this you can write minus log 1 by you can write it 10 to the power minus 2. So it will be coming around half 4 into 7 4 plus 2, and so it will be coming around 3.37. So this will be the right answer. Okay. If the dissociation constant of 5 into 10 to the power minus 4 molar aqueous solution of dimethylamine is this, then you have to calculate the pH of the resulting solution. So for that, what we will do, first we have to dissociation reaction, we have to write, that is the methylamine, that's ethylamine, C2H5NH, and when it will be reacted with water and it will make a dissociation equation is this, C2H5NH plus NH2 plus, and it will give OH minus. So you see the base, and it is taking the H plus ion from H2O, it acts as an acid and it will give this. Suppose initial concentration C, then 0 mole per second, then after the degree of taking the degree of dissociation alpha, you will get this. The similar way we already calculated. So we get the K, that is C alpha into C alpha by C minus C alpha, that is C square alpha square by C into 1 minus alpha, and it will be C alpha square. After taking the approximation, you can neglect the 1 minus alpha square. So from this we can calculate, first let us calculate its degree of dissociation, that is given by this A by C, because both this value has been given here. What is this? Now dissociation constant is this, so we will write this 2.5 into 10 to the power minus 5 divided by, we will write 5 into 10 to the power this, and if we calculate, we will get this is around 0.22. So we have to calculate the pH, but we will get the concentration of OH. Then concentration of OH is given by C into alpha. C is given by what? Now it is given this 5 into 10 to the power minus 4 into 0.22. So it will be coming around, this value will be coming around, if we calculate, it will coming around, how much it is coming, that we have to calculate it. It will be coming around 22 into 5, 10, this will be coming 1.1 into 10 to the power minus 4. Okay. Now we know this relationship, H plus ion concentration into the product of this Kw value, then it 10 to the power minus 14. So if we put this value, we get this H plus ion concentration, that will be 10 to the power minus 14 by 1 into 1 into 10 to the power minus 4, and it will giving around 1 by 1 into 10 to the power minus 10. So pH is minus log of this value 1 by 1.1 into 10 to the power minus 10. So it will be coming around 10.04. If we calculate, you will find this. So this will be the right answer. Okay. So I think the conception of the Ka, this is a constant, and this is constant of base and acid is clear to you. And how do you able to calculate the pH from the different data, different information given in the sums? That degree of dissociation of Ka value has been given, Kb value has been given. So we can able to calculate all these things. So that is all for today's video, and in the next video we will understand the hydrolysis. That is a very important part of this ionic equilibrium chapter. And if you like this video, you can share to your friends, and thank you very much for seeing this video. Thank you very much.